It doesn't matter whether your line is straight, whether your line is curved like this or curved like that. If you have a line or a function that's increasing from left to right, that means you have y dash is greater than 0. That just means that y dash is going to be positive. So let me just write that down real quick. I'll just put a positive over here, okay? Now let's take a look at another 3 lines, similar to these, but a little bit different. So with these lines over here, I have a straight line, curved, curved. It doesn't matter if it's straight or curved. If it is decreasing from left to right, then what we have is y dash is less than 0, which means that y dash is going to be negative. So now that I've gone over what happens when y dash is positive and what happens when y dash is negative, what happens when y dash is right in the middle of the two? What happens when y dash is equal to 0? Well, what happens when y dash is equal to 0 is we have a stationary point, right? Now, a stationary point can also be called a turning point. And that's what I have this marvelous diagram here to show you guys kind of how this works, all right? So, all right, I want you to think about driving a car, okay? Imagine you're driving a car through this suburb here, and there's so many hills in this area, right? Now, you just want to find a place that you can park your car. But here's the thing, right? Your car doesn't have any functioning brakes. So if I park the car over here, then my car's just going to roll straight down. And I don't want that to happen. If I park my car over here, the car's going to roll straight down. And so I can't leave it stationary over there, right? If I put my car over here, it's just going to roll straight down. I don't want that either. But here's the thing, guys. If I park my car all the way at the top of this hill, right at the peak here, well, I can see that my car will be able to sit perfectly stationary without falling down, right? And since my car can be stationary here, I'm going to call that a stationary point on all this hilly area. And in maths, you don't call it a little hilly area, you call it a function, right? So this is one stationary point within my function. Now, is there another stationary point? Well, if I take a look down the bottom here, at the bottom of this valley, I can see that my car can remain perfectly still, right? Perfectly stationary. That means I got another stationary point here. Now, there is also another one right in the middle over here, marked by the dot there. If I park my car here, it's not going to roll in either direction. It's just going to stay perfectly stationary. So that's another way that you can think of stationary points. So now that you know what stationary points are, or turning points, I'm going to show you exactly how to find them if you're given a question where they just give you the equation, right? So let's take a look at this example over here. All right. If I have y equals to x to the power of 4 minus 2x cubed, and we're being asked to find out what the stationary point or stationary points are of this equation, all you need to do is remember back to over here, okay? Over here, I said stationary points occur when y dash is equal to 0. So all we need to do to find the stationary points of y equals x to the power of 4 minus 2x cubed is to let x dash equal to 0. So let's take a look. I differentiated that already. So y dash is just equal to 4x cubed minus 6x squared. And then what you want to do is say let y dash equal to 0. And once you let y dash equal to 0, then you're going to come up with an equation with just x and numbers. And you can quickly solve this for what x is equal to. All you have to do is factorize, right? So once we factorize, we get 2x squared times 2x minus 3. Since there's two things multiplying to give you 0, you can make either of those things equal to 0. So you got 2x squared equals 0, 2x minus 3 equals 0. And then you come up with two values of x, right? You come up with x equals 0 and x equals to 3 on 2. And you're probably wondering, okay, great, I found x, but wasn't I trying to find something called a stationary point? And remember, guys, with the word point, you need an x coordinate and you need a y coordinate, right? So over here, I just found out two x coordinates. This is the x coordinate of my first stationary point, and this is the x coordinate of my second stationary point. So what I'm going to do now is find out what the y coordinate is at these values of x, right? So I just have to substitute x equals 0 into my original equation, and I'll get y equals to 0 minus 0. So then y is just equal to 0, right? I do the exact same thing for over here, x equals 3 on 2, sub that into my original equation, and I plugged it in the calculator already, I get y is equal to, actually, no, I don't think that's right. I think that was 27. Oh no, I can't remember from memory. I think I just guessed that one. Okay, negative 27 on 16, I don't know. Okay, and then I can just put these points together, well, these coordinates together. So I have x equals 0, y equals 0, and that means I have my first stationary point at 0, 0, and then my second stationary point is at 3 on 2, negative 27 on 16. Okay, so that's how you find your stationary points. Now that I've shown you guys how to find stationary points and what exactly they are, let's take a look at the 3 different types of stationary points that you can have and how to determine what stationary point is which type. So the first one we have over here, that looks like the top of the mountain. This is what we call a maximum maximum stationary point or maximum turning point. Now, all the way at the bottom over here, this is what we call a minimum turning point. So just remember it as like, you know, small, minimum, all the way down here. Now this middle one over here, this one looks a little strange, right? That middle one has a special name for itself. It's not the top of the hill, it's not the bottom of the hill, but it's kind of an in the middle. And what we call this in the middle kind of stationary point is a point of inflection. Okay, great. So those are our 3 different types of stationary points. Now let me go through another thing with you guys, thinking about what we did at the start of this video. Well, thinking about those lines there, let's think to ourselves, okay, what is the gradient of this line over here, just before this maximum stationary point? So before the maximum stationary point, we have a line that looks like it's increasing from left to right. If it's increasing from left to right, that means y dash is positive, right? So I'm gonna put a plus sign over here. Now, past the maximum stationary point, we have a line that's going downwards from left to right. And that means we have a negative gradient or a negative y dash. So I'm just gonna draw that in here. And now let's take a look at our point of inflection. Well, to the left of the point of inflection, I can already see I have a line with a negative gradient. And now over here, to the right of our point of inflection, I can see I have a line that's decreasing. And if the line is decreasing, remember, y dash is negative. So I'm gonna put a minus sign over here. Now, let's take a look at this minimum point. Well, what's to the right of this minimum point? We have a line increasing, so that means we have a positive gradient. So I want you guys to notice that a maximum turning point is surrounded by y dash being positive on the left side and then y dash being negative on the right side, or a line that's increasing and then it goes to the top and then it's decreasing. Now with a point of inflection, we can see that there's a line that's decreasing and then our point of inflection, and then the line is decreasing again. Now there also is another way that you can have a point of inflection, and that's kind of the opposite, all right? Imagine if our line was kind of like that. Then what we have is a positive gradient here and a positive gradient here. So a point of inflection is either surrounded by a negative and a negative, or your point of inflection can also be a positive and a positive, okay? Now with your minimum, it's surrounded with a negative on the left and a positive y dash on the right side. Now this is really important to remember for what we're about to do next, okay? So what's the actual mathematical way of finding out whether your stationary point is a maximum, a point of inflection, or a minimum? Well, that's what we have this technique called the Y table for, right? And with the Y table, it just helps us determine whether it's a maximum, minimum, or point of inflection. So let me show you guys how that actually works. So jumping back to the example that we were doing before, we found 2 stationary points, right? One was at x equals 0, one was at x equals 3 on 2. So what you want to focus on here in your y dash table is a row of x values and a row of y dash values, okay? And okay, so how we're going to start this off is by writing in the x values that we just found out, 0 and 3 on 2. We always need to do this in order. So I'll put the 0 over here, and I'll put the 3 on 2 over here. Make sure you leave a gap of 1 here, a gap of 1 here, and a gap of 1 there. The point of that is so that we remember that these are our stationary points, right? And we need to find out the gradient of what's left of the stationary point and what's right of the stationary point. What's left of the stationary point and what's right of the stationary point. Because remember, a max is surrounded by a positive and a negative, right? Point of inflection can either be negative, negative, or positive, positive, and a minimum is surrounded by a negative and a positive. So let's see what this is in action, all right? So, okay, now what we need to do is choose x values to sub into our y dash equation. And with the x values, I want to put them in order, right? So what's something a little bit below 0? Well, that number is going to be -1. What's something a little bit above 0, but a little bit less than 3 on 2? That number is going to be the number 1. And what's a little something above 3 on 2? That's going to be a 2. So now that I've selected all these x values, I'm going to substitute them into my y dash equation. So that's going to be, and it's going to be this. Okay, so now that I've figured out all of my y dash values, well, remember, I need to think about whether y dash is positive or negative, right? So with -10, y dash equals -10, well, that's negative. So what does that line look like? It looks like it's decreasing from left to right. Now, if I have y dash equals 0, well, that's just my stationary point, right? Now, when y dash is negative, that means I have a line that's decreasing. So it looks a little something like that. Now, if I have a y dash of 0, that's just a stationary point, and a y dash of 8, well, that's just going to be positive. So that means my line is increasing. So what I can see I have here is a stationary point surrounded by a negative gradient and a negative gradient. Now, thinking back to this diagram here, if I have a stationary point that's surrounded by a negative gradient and a negative gradient, well, what is it? It's going to be a point of inflection, yeah? So I can say that therefore, at the point where x is equal to 0, and what's the y coordinate again? It's not 0 here, but okay, it was 0, it was y equals 0 there. So yeah, just don't get confused and write your coordinate as x and y dash. It's just x and y, right? Now let's think about our other point. Wait, so 0, 0 is a point of inflection. Okay, now let's think about the other point. Well, if I have a stationary point surrounded by a negative gradient and a positive gradient, well, what do I have? So negative on the left, positive on the right. Well, that looks like my minimum over here. It's got a negative gradient here, positive gradient here. So therefore, the point 3/2, -27 on 4, is a, cutting into the graph here, but don't worry about that, is a minimum stationary point or minimum turning point. So now that I've finished that off, I want to sketch out what I actually have, right? And as soon as you find out your stationary points and what kind of stationary points you have, you can easily just sketch out what this is. So looking at the Cartesian plane here, 0, 0, that's a point of inflection, right? So 0, 0, that's just over here. Now remember, back to the graph, you have a negative gradient and a negative gradient. And what does that look like over here? Well, it looks like a line that's going down and then another line that's going downwards. So I'm just going to draw that real quick. That's going to be a little something like this. Okay, that was terrible. Okay, let me just retry that. Okay. So, yep. Okay. When you're sketching your stationary points, you just want to put down what each of your points are at. So 0, 0, that's just over here. Let's start off with that one. Remember that our stationary point 0, 0 is actually a point of inflection. And this point of inflection kind of looks a little something like this. It's a line that's decreasing. You have your stationary point, and then it keeps on decreasing, right? So it's going to look a little something like this. Like that, and like that. Okay, so that's what our point of inflection looks like. So now let's think about the minimum that we have over here. Well, the minimum is about at 3 on 2 and -27 on 4. Let's just say that's about down here, all right? So if I wanted to draw my minimum, I'm just going to curve this up like that, put some arrows on the ends there, and I'm going to label this in as 3 on 2, and down here it's going to be a negative y coordinate of -27 on 4. And what I have here is my graph, right? You have to make sure you label in everything. It looks like pretty much everything is labeled. Probably what you might want to do is find out what this x-intercept is. Whenever you have any intercepts, always try and find them, all right? And then that's going to make your diagram look very, very nice. And also when you're doing it, please use a ruler for your axes. Okay, so yep, that's it for this question. Okay, so just a little bit of a recap. Whenever you're trying to sketch with stationary points, step number 1 is to find out what your stationary points actually are. So that means the x coordinate and the y coordinate of your stationary point. You do that by allowing y dash to equal to 0 and solving that equation, right? Now, the next step, once you have your 2 stationary points or 3 stationary points or 1 stationary point, you need to find out what type of stationary point you have by doing a y dash table. So remember, you need to put your x coordinates that you just found in the second and the 4th slot, and the numbers around it, well, that's up to you to decide. And that's how you can find out what your y dash is going to be, whether it's going to be positive, negative, or negative, positive, or negative, negative, or positive, positive. And that eventually helps you find out whether your stationary points are maximums, minimums, or points of inflection. So good luck with your questions.